Hello guys, in this video I am going to explain the solution of this question number 26 from chapter 11 of the book Engineering Circuit Analysis by Hayt, Kemmerly and Derwin. So the question says that for this given circuit we need to assume that the operating frequency is 40 radian per second and the load impedance is this 50 angle minus 100 degree. We need to calculate the instantaneous power separately delivered to the load, this load, and 1 kilo ohm shunt resistance at t equals to 20 milliseconds. Then we need to determine the average power delivered to both the passive elements, then the apparent power delivered to the load and the power factor at each source. So first of all, to solve this question we need to know the current, and to determine the current we need to solve this circuit. Like over here the load is given as 50 like Z is equals to 50 angle minus 100, and this we can convert this into, or this is 50 impedance, this is impedance, so it is ohms, right? Or we can write this as, we can convert this into kilo ohms, so it will be this. So our load is 0.05 angle minus 100 kilo ohm. Now in this circuit to get the current we can use the mesh analysis, or we can use any other theorem you like. So just we need to determine the current and voltage across all the elements of the circuit, right? So if I apply the mesh, so over here in the circuit 1 already the current is given like this, so directly I can get I1 equals to 275 angle 20 degree milliamperes, right? Now if I apply the KVL in the second loop, so over here we have one current going in upward direction having two components of current, one I2 going up, I1 coming down. So it means this current that is going up, or let me take the, yes, the current that is going up, it is I2 minus I1, and the resistance is 1 kilo ohm. I simply write 1 kilo. Why? Because I am calculating this I1 and I2 I am calculating in milliampere. So it is the reason that I convert, use kilo ohm in both the cases. So for this we get the voltage across 1 kilo ohm is I2 minus I1 into 1, and then coming over here, so it is plus minus, so plus load is this 0.05 minus 100, right, into current is I2 equal to 0. Now I1 we already know from here, so substituting and solving this we will get I2 as 277.78 22.89. To know how you can get this I1 and I2 value, you can refer to my previous lecture on this same chapter. Over there I have mentioned in detail how we can get these values, how we can solve this equation simultaneously, right? So once we get I1 and I2, now we can determine this current I. So our I, it will be I1 minus I2. Why I1 minus I2? Because the direction of I, this direction of I, it is in line with the direction of I1, right? So I is equals to I1 minus I2. Now substituting the value of I1 and I2 and solving for this I, so I will get I will be equals to 14.21 79.83 milliampere. So once I get I1, I2 and I3, then from this I can determine the voltage also. So voltage across this 1 kilo ohm, it will be simply I into 1, right? We will not use K because current is in milliamperes. So simply it will be same, 14.21 angle 79.83 volt. Right, now similarly we can determine the voltage across the load. So it is Z into I2, because the current flowing through the load is I2. So load it is 0.05 angle minus 100 into I2. I2 is 277.78, angle is 22.89. Right, and now solving this, we will get it as 13.89, angle is 77 point minus 77 11 minus 77.11. Right, so this is our VL, volt. So once we get all the current and all the voltages, now we can come to the question, and the question, first part of the question says that we need to determine the instantaneous power separately delivered to the load and 1K at t equals to this. Right, so for this A part, first we need to write the instantaneous current. So instantaneous current for 1K, it will be like, we know that this is the current, right, and this current can be written in this form as 14.21 cos omega t plus 79.83 milliampere. Right, now 14.21 cos omega is given in the question, it is 40. Right, so it is 40, so 40 t plus 79.83 milliampere. So this same thing I can substitute over here. So pt is equals to it, so it is 14.21 cos 40 t plus 79.83 multiply with v 1K, this one. Now over here Vm is this, angle is this. Right, so it is 14.21 cos 40 t plus 79.83, and this will be, now over here the current unit of current it is milliampere and the unit of voltage is volt, so we will get answer is milliwatt. Right, and substituting, because we need to determine the current at 20 milliseconds, so substituting this value 20 milliseconds means, which is 0.02 seconds. So substituting this value over here and here and solving this, you will get the answer is 67.926 milliwatt. Right, and similarly for PL T, we know the current through load, it is I2, this current. Right, so it is 277.78 cos omega t plus 22.89. Right, and then voltage, it is this, so it is 13.89 cos omega t minus 77.11. and now substituting, this is the instantaneous and unit is milliwatt, and substituting again 20 milliseconds, so you can substitute this value and you can get the answer. Right, now coming to the B part, the power delivered to the average power delivered to both the passive element. Now for the average power B, we know average power. It is given as half Im cos theta, and where theta is the angle between the voltage and the current, with voltage leading the current, so over here the average power, capital P for 1K and capital P for L, so it will be half. Now for the 1K, the Im and Vm is this, so it is 14.21 into 14.21, and the angle between, like both the angles are same, so it is 0. Cos 0 is 1, so you will get it as 10.96 milliwatt, right? And similarly for the PLT, half, this is Im, this is Vm, so 277.78 into Vm into cos. Now the angle between this 22.89 and this, it is, the angle is, let me calculate, just a minute. So since the angle, like this is the voltage angle, so it will be minus 77.11 minus, and this is the current angle, so it will be minus 22.89, so this we will get it as 90. Let me also try with the calculator. 22, it is 100, we are getting it as 100 degree, right? So it is cos 100 degree. And now if we solve this particular, so we will get, just a minute, let me calculate cos, what is cos 100. Just a minute, cos 90. Yes. So cos 100, it is minus 0.1. Okay, it is not 100, it is minus 100, so it will be plus 0.174. And now solving this, we will get 270, multiplying with 277.78 cross 13.89 divided by 2, we will get 334.99 milliwatt, right? So let me check it once again. 278 into divided by 2 into 0.174. Yes, so it is something this. So this is the average power for the 1 kilo ohm shunt and the load. Now the third part of the question says we need to determine the apparent power delivered to the load. So to determine this, we need to determine the apparent power. The formula for apparent power, it is V effective into I effective, or we know V effective is Vm by root 2, I effective is Im by root 2, so it is simply half Vm Im, right? So the apparent power for the load PL, apparent. It is equals to half into this same thing. Only cos 100 will not be there. So it will be 277.78 into 13.89. So it will be 1929.18 milliwatt. Right? So this is our apparent power. Right. Now coming to the next question, next part of the question. It is saying that the power factor at the power, we need to determine the power factor at which the source is operating. Right, now at which the source is operating means that we know this is the voltage, I1 is the current, sorry, this is the current. So we need to determine what is the voltage across this. Right, so the voltage across this source, it will be the voltage across this 1 kilo ohm because both are parallel. So it means to calculate the power factor, we need to determine power. Power factor. We know that power factor is equals to cos theta, where theta is the angle between the voltage and the current, with voltage leading the current. Right. So we need to determine like what is the angle of this shunt. So over here the angle, like it is mentioned over here. So the angle it is 79.83. Right, and over here the angle is 20. So the cos theta it will be 79.83 minus 20. So it will be simply cos 59.83. So cos 59.83, it will be 0.503. So the answer to this last part, it is 0.503. Right. So this is the solution to this question number 36. So if you have any doubt, you can put it in the comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.